Here's an example where you have variables underneath your radical symbol. So your radicand has variables in it. So we have the square root of 525, x to the fourth, y to the fifth, z to the fifth. So we're going to find the prime factorization of this, which is going to end up being 3 times 5 squared times 7 is the prime factorization for 525. X to the fourth, y to the fifth, z to the fifth. Looking at those all individually makes it a little bit easier for us to simplify. We know that this 5 here, square root of 5 squared becomes just 5. 3 stays a 3, 7 stays a 7. X to the 4 stays x to the 4. Y to the fifth, we split up into y to the fourth and y. You'll see why in the next statement or the next step. Z to the fifth becomes z to the 4 and z. X to the fourth is the square root of x to the fourth is x squared. The square root of y to the fourth is y squared. The square root of z to the fourth is z squared. So we have square root of 3 times 5 times the square root of 7 times x squared times y squared times the square root of y times z squared times the square root of z. We put together everything that's not under a radical out in front. So 5x squared, y squared, z squared. We put everything that's underneath a radical together. So 3 times 7 becomes 21, y, z. So you could also, if you liked the way that I had done this before, you wouldn't go all the way to 3, 5 squared, 7. You would stay at 25 and 21. And square root of 25 is 5, which brings that out right away. Why does the final answer include square root of 21 when square root of 21 does not appear in the previous step? Write down your answer for that and have it ready to go for later.